Hello, everyone. My name is Hanieh Alipour. My colleague Kohinoor also is in this call. Today we are gonna talk about our survey paper that was focusing on the ChatGPT alternative solutions. So we are at an exciting point in AI development where ChatGPT has changed how we talk to machines. But there is a whole world of other AI like ChatGPT. So there are lots of alternative solutions full of new ideas and improvements. In our paper, we try to look at these different options, which are creative, efficient, and also can use for our needs. So today, I'm gonna present you what we discover, and we're gonna talk about some of those technologies. We have lots of details in our paper that we don't have time to present it in these presentations, but if you like, you can read our paper. And also, we are going to see the challenges about LLMs, large language model like ChatGPTs in general, and what next, what we can do for the future. So let's just start with what is LLM, because ChatGPT, GPT series, those are all part of the large language models. Large language model is a type of artificial intelligence that processes and generates human-like text based on learning from a huge database of existing languages. So we need a huge data sets. So it can understand queries, it can provide answers, create content based on different topics and different languages. So LLMs are used in many areas like automating customer support, creating content, translating the language, and also for educational resources. So the goal is to making tasks easier and more accessible. So large language models can be customized for specific jobs of area or some specific areas. Also can handle large amount of data to get better results. It's talk like human kindly, and also can giving the relevant replies based off what we ask from it. So a lot of people think large language models came to our life around early of 20 centuries, 2010. But honestly, a lot of people think ELIZA is the first one. ELIZA was created in early 1916s at MIT, and it's one of the first computer programs that could talk like a human. It's seen as an early version of chatbot that we can see right now. It's much simpler, for sure. We didn't have transformer, we didn't have that large amount of data, but ELIZA helped to start the idea behind how computers understand and talk to the people. So the history of large language models start with the early work on natural language processing, and very fast progressed over the last decade, like thanks to the better deep learning techniques, more powerful computers, and lots of data that we have right now. So initially, the idea was to use statistics to help computers to understand language, which has been around since mid-20th century. The real game changer came with the neural network in the late early 2010, especially when we had some word embedding like word2vec in 2013. So it helped the models to grasp the meaning of the words. So during this revolution, the development of the transformer architecture in 2017 was a major leap. So making it easier for model to process text in parallel and understanding the context better. So after that, around 2018, OpenAI GPT series, and after that, Google BERT, they are all a huge achievement and milestone in LLM history. So they are significantly improving how well LLM can generate and understand text. So it was a big journey. These LLM models that you can see in this slide are all presented in our paper with the details and lots of benchmarking results. So we're gonna review some of them, not all of them here in these presentations. But before goes further, let's have a little review about prompt engineering. Why prompt or prompt engineering? Because prompt is like a question or instruction you give to an LLM to get it to do something for you, like writing a story or answering a question. So prompt engineering is the skill of crafting these instructions really well to make the model understand exactly what you want. So it is important because the better you are at telling the model what to do, the better the model will be at giving you the kind of answer to help or you are looking for it. So it's like knowing the right way to ask for what you need so you can get the best possible response. So we have different techniques for prompting. The basic one, it's basic, it's a first version, but it's not like, it's a simple one, but it doesn't mean we don't get the good result. It's a basic and simple prompting is a zero-shot learning, means the model can understand and do a task which is never seen before. So it's just from your instructions. And meanwhile, few-shot learning is when the model learns from just few examples to get the better at the task. So you give the model few examples, then you ask your question or you give the prompt. So based off those examples, the model can generate the result that you want based off the prompt you introduced. Another technique is the chain of thought is a bit different. So it's like showing your work in a mathematics. The model breaks down the problem in the steps and works through them only one by one to find the answer. So zero shot is about jumping straight in, few shot is about learning from few hints, and chain of thought is about solving problems step by step. So these are the how we talk to LLM in a very general view. Okay, OpenAI. Yes, it's a big name, big change, and big revolution. OpenAI has made a big advancement in LLM, no doubt, especially with the GPT series models. It's improving how LLM understand and uses the languages. So they support sharing language and working together ethically. So their effort have led to new LLM users in many fields. So we know after ChatGPT, after OpenAI released ChatGPT, a lots of things change and a lots of people think to their problem in a different way and how you can use LLM in their field or in industry. There are so many achievements in OpenAI has so many achievements, but here we're gonna just talk about GPT and a little about DALL-E. So GPT, Generative Pre-trained Transformer Series. A series of language models developed by OpenAI for sure. So, and designed to understand and generate human-like text based on input that it received. GPT, so it's a series of the language models. GPT-1 released around 2018. It's the first in the series, so for sure there are so many limitations, some challenges, but it's setting the foundation with the transformer architecture for sure. After that, 2019, GPT-2 came. The model size significantly increased. It was bigger, and it's improved in the ability to generate more current and contextually relevant text for sure. But 2020 GPT-3 introduced to the world, it was being one of the largest language model at the time at it's released, which is like 2020. And that time, if I remember correctly, it was 175 billion parameters. The model capable of writing articles, poems, summarizing tasks, text, translating language, lots of things with a minimal input. You just give a 1 or 2 sentence of a prompt and you can have like a summary of the PDF. It was huge. After that, recently they have GPT-4. So what's the difference between 4 and the rest of this GPT models? GPT-4 has a bigger context window, which means it can understand larger chunk of text at once, making its response more accurate and well connected for sure. It's better at chatting and making conversations feel more natural, can keep up with longer discussion that makes sense. So it's much more useful. It's get connected to the internet. It's more up to date, the information that generated by GPT-4. So these are the journey of the GPT series, but we know that the transformer architecture is a foundation of the GPT series. It's it's a breakthrough in a natural language processing that enable models to process text in a way that capture a long range of dependencies, meaning it can understand context from the word that are far apart in the text. It's not like a previous models. The previous models process the text sequentially, one word after the next, but the transformers use the mechanism called attention. So what attention do, it's to weigh the importance of the different words relative to each other. Doesn't matter where it's in the sentence. The position in the sentence doesn't matter. They're just looking to this relation. So for sure, this allowed the model to capture the relations in the language more efficiently. So transformer, they have two main parts, encoder and decoder. The encoder, which read and processes the input text, and decoder, which generates the output text. Model like a GPT, they use only decoder part. So they applying it in a autoregressive manner to generate text based on the probabilities of what word come next. So informed by the context of the previous words that we have. So that's how the transformer architecture works for GPT, just the decoder part. So this type of architecture, it has a significant improvement in the text generation tasks. So because it's enable the models to produce more current and contextually relevant and across the wide range of the applications. The next achievement was DALL-E. DALL-E, DALL-E is another OpenAI service with generating the image from text, which is it's combined understanding of the natural language with the image generation capabilities. For sure, it's using the different version of the GPT. Sorry. So one of the key features of the DALL-E is it's very creative, it's flexible. You can see a lot of details in the image that the DALL-E generated. and the higher resolution in the images, and it can mimic different artist style and generate image based on that. Okay, GPT series. It's very powerful, amazing result for sure. But we have in industry or in research, we have different needs, uh, or some of us, based off some challenges, we cannot access to GPT. But there are other alternative solution in the market, from both point of view, researchers or the industry people for the commercial. One of them is Llama, the large language model Meta AI. Llama refers to the state-of-the-art of language model developed by Facebook AI. Right now, they call it Meta AI. So it's designed to be efficient and powerful. But at the same time, it's allowing the researchers or developers that have a limited computational resources to still enjoy the power of the LLM. This is the significant part in Llama. Llama, it's try to face the problem with the computational resources. They say, okay, if you have, you can still have a good LLM with a good result while you have a limited computation resources. So Llama at the beginning, when they released it, it was just for researchers, and we couldn't use it for commercial. But right now, Llama 2, it's available for the commercial use. So as I mentioned, the efficiency and the scalability of the Llama is one of the features, because Llama is designed to be efficient in terms of computational resources. It's so you're allowing to scale across different hardware setup. So this is great for the for the researcher, for students. Also, you can use it for a different range of application, has a high performance. There are so many papers, officially industry-wise, you cannot find any record that say, for example, Llama 2 is better than GPT series. But in the research area, you can in academic, you can see papers that based off different application. The people did a lot of benchmarking and try to compare the performance of Llama with the GPT 3 and GPT 3.5, and they have a very close result. So even I used Llama 2 for some POC, and I could see that they are efficient. The performance is good. Sorry, and it's accessible for sure. The next solution is a GPT-Neox. What is the highlight in the GPT-Neox? Is it open source? It's a large language model developed by the Alipour AI community, and it's created as an open source alternatives to GPT-3. So the big point is it's open source. So one of the most significant feature for sure is scalable. So you can train it in a different range of hardware setup for individual GPU or larger cluster. It's accessible. You can still run the GPT-Neox a different hardware setup, and because it's open source, so it's allow the users to fine-tune the model on a specific data set or for particular application or enhancing their GPT Next. So it's a big win for GPT Next. For sure, when we talk about big company like OpenAI, Microsoft, Amazon, Google's, they are not they are part of this game. They do their own stuff. So we have Google generative AI. Google generative AI is a type of AI which is for Google, developed by Google. you can create new content like text, images, music, and it's a resemblance of the human-made content. So they are very efficient and very famous, and they did a big part of this revolution. Like T4. T4 is a text-to-text transfer transformer. It's a very light LLM. Easily you can access it, and for some tasks like a summary or email, summary or text, or it's doing a very nice job. It's the result, it's accurate, and it's very light LLM. The next one is BERT, bidirectional encoder representations from transformers. We believe that birds play a big role in this revolution because it's powerful language model, and it's known for the ability to understand the context of the word in text by looking at them from both directions, left to right and right to left at once. So this is the key feature. So compared to other models just looking to one direction, BERT can look at both direction and both direction at once. So it means it helps to understand the full context of the word based on all of its surrounding. And BERT is based on the transformer architecture. BERT is the first pre-trained model, and you can fine-tune it. It's a support wide range of the applications, have a really high performance, and it's very popular. Industry and academy people use it a lot. We talk about a lots of things. We know everybody talk about ChatGPT. Everybody talk about LLMs and these revolutions, but we are talking about all the advantages we can have from those models. But let's talk about the challenges, especially in the research area or industry even. We are facing challenges, no doubt. One of them is LLM needs a lots of computer power to work well, which can be expensive. So using cheaper or less powerful computers may make it slower, less accurate, or cause other problems. So businesses or the students needs to check, or academic, or they need to check if they have a strong and enough computation resources, let's say, before using LLM. So that's a limitation. Not everybody access to this kind of computational resources. Also, LLM models have a lot of parameters, which is making it complex and needing a lots of computer power, money to work. So many parameters can also lead to mistakes, biases from the training data, and make it hard to keep model accurate without using too many resources. So finding the right balance of parameters to keep model working well without making it too complicated, it's a big challenge, really big. So imagine GPT has we don't tune 175 billion parameters, but still if we want to have an accurate result, we need to tune at least quite a good number of parameters. So keeping another things up to date, put the model be up to date. It's like keeping it regularly updating with the new data. It's necessary. It's not necessary. It's mandatory kind of, because we need. If you don't update the model, they might start giving a wrong or output information. So that's also another challenge. So also we need a lots of data. Having access to those large amount of data, it's also important. The cost, the computational people, equipment, they are all expensive. So that's we need to think about it. There are lots of the data in internet include lots of information, personal information. Yes, they are not supposed to share it. They are not supposed to save it, but by mistake, it can get involved in the training or published. So that's also privacy is a big issue for the uh, for the for the LLMs researchers. I don't have that much time, so I'm going to go fast. So what does we do for the future? Yes, people say GPT, we are waiting for the GPT-5, GPT-6, but there are other approaches that we can look and go forward. We don't need always go like a next model or bigger model. We can look at another aspects for the future in the large language model area. For example, what if for the training the model we need a big and huge database or the large of the data? What if the model can create their own training data while they do training at the same time use that data for the next training? So uh, so won't be limited to that the data we introduce to the model. People are working on it. Google is working on it. So this is the one approach, one path for the research. We are looking at it to say, okay, new LLM models are to be able. We have a new LLM models are being made that can create their own training data, which is a big steps forward. The second one that we can look to it is that always the accuracy is important, to be sure the information is correct, transparency. So we need to know we can rely the data that or the information that the LLM provide for us are reliable. So they are looking, so now the researchers are looking at this part that, okay, how we can LLM provide references or how we can be sure the information are correct. So validate the information. The model can be able to validate their own information. The third approach, which is also these days are very popular, people are looking at it, is that LLM is big, a lots of parameters. We need to tune a lots of parameters. What if for a specific problem, for a specific area in industry or research, we just use part of the LLM, we just tune some of the parameters to make it like a model. We have a model and we have sub models, a smaller version of that. I'm not saying we don't have it, it's a future that's coming. We are working on it, but these are also the approaches that we can look at it when we are talking about the future of LLM instead of just thinking about GPT-5, GPT-6. So that's just a talk. So in our paper, we review several surveys, several papers, and each of them review and cover different aspects. What we did differently is that we are looking at the industry part and we look at the alternative solution, we look at the comparison between the GPT with other LLMs, which hardware we need, which parameters we need, what the performance, and so that's our difference between us and other surveys. Thanks